At the point when the $10 billion gadget prepared its infrared vision on the exoplanet K218b 120 light-years away, it distinguished dimethyl sulfide, a sulfur compound that, on Earth, is created solely by life forms. Does this imply that the matter is settled? Might we at last answer the oldest question of humankind, whether we are truly alone in the universe, with a clear no? Well, that is precisely the essence of the cosmic discussion. While one side of the specialists is already popping the champagne corks, the opposite side is calling for a little more patience and pointing out that even the abilities of the most remarkable space telescope of all time are limited. Hand on heart, in most individuals' daily routines, dimethyl sulfide, or DMS for short, likely plays no significant role. In fact, the majority of people have probably never even heard of this specific chemical compound, although they have likely encountered it at one time or another. DMS is formed by tiny green algae, the phytoplankton, which float in the upper layers of the sea. It's responsible for the common smell we notice when we are at the beach. Apart from its scent, DMS also has another important characteristic. Up until this point, we are only aware of biological sources for this sulfur compound, and where the creation of a substance needs the support of organisms, it's understandable that DMS plays a very special role in the search for extraterrestrial life. This brings us to the calls of happiness that came from the lips of the Cambridge space experts in September 2023. After all, the James Webb telescope had identified nothing less than this potential biosignature on the exoplanet K218b. The overwhelmed pioneer, Nika Matuson, then told the press that he and his associates were totally stunned by their readings. No wonder, because the presence of DMS in the vastness of space is nothing short of a serious sign of extraterrestrial life. What at first came as a shock to the scientists soon turned into almost euphoric reporting, which casually raised the James Webb telescope to the key to the astronomical search for life. However, is the matter, in fact, as clear as it seems? If the corresponding atom on Earth is only produced by living things, and we then find it on an alien body, why hasn't NASA officially announced that our minute neighbors are thriving on K218b? Well, that's because, as so often, the unseen details are the main problem. But, essentially, the conditions regarding K218b are anything but bad. K218b is a water world, a potential haven for life located around 120 light-years away from us in the Leo constellation. The planet is under the astonishing suspicion of being an ocean planet. In other words, a planet whose surface is completely covered with water and could therefore support life. And while K218b was added to the star charts in 2015 with the help of the Kepler Space Telescope, it orbits its central star, the red dwarf K218, within the habitable zone. This, in turn, describes the distance range at which a planet should be found relative to its host star for water to exist there in a permanent liquid form. Of course, the cool, wet element is considered one of the key points of support for the development of life like that on Earth. Although K218b is significantly cooler than the Sun, its planetary companion receives roughly the same radiation as our Earth due to the given star system. Essentially, K218b is just 0.14 astronomical units away from its parent star, so it requires only 33 days for a complete orbit. And, indeed, the key segment in this life conversation list also contains the elements methane and carbon dioxide, which suggests that we may actually be dealing with a habitable planet here. If this is indeed the case, it would be a huge curiosity since, up until now, these intriguing water worlds have only existed on paper. However, while large amounts of methane and carbon dioxide, combined with the absence of ammonia, suggest that K218b is a Neptune-like planet covered by liquid water, the identified substances present another complexity. They make it even harder to interpret the DMS data accurately. The secret of the biosignature is that, fundamentally, the DMS signal was hardly noticeable in the collected data, and it only revealed itself when the data was analyzed in a distinctive way. The matter was not made any less complicated by the fact that the DMS signature detected by Webb's near-infrared spectrometer appeared in a spectral line at a frequency of 3.4 micrometers. This frequency, therefore, overlapped with that of methane. And that's exactly the crux of the matter, because the scientists believe that detecting DMS in methane is essentially beyond the capabilities of near-IR spectrometers. But does this also mean that Webb's capabilities have already been completely exhausted and that we cannot uncover the true background of the DMS question? Well, fortunately, no. The scientists also emphasize that definitive confirmation is, in principle, possible. After all, DMS and its breakdown products also produce a signature in the mid-infrared range, between 9 and 13 micrometers. Conveniently, this is the very range in which Webb's MIRI spectrometer works. While the initial NASA statement still discussed a potential detection of the molecule dimethyl sulfide in this context, the Cambridge researchers eventually wanted to know more. As it turned out, the space experts once again used Webb's sharp infrared vision to get to the bottom of the mystery surrounding the so-called biosignature. In the process, the scientists allowed 8 hours for the designated search for DMS. 1 to 2 days later, the research team would then receive the data and begin their analysis. Anyway, it's in the nature of things that such data analysis is, to say the least, a lengthy process. In other words, it will take quite a few months before it is fully completed. The good news, however, is that the scientists have already been working on the investigation for several months, and it shouldn't take much longer before the latest findings of the presence of DMS on K218b are published. Meanwhile, the rest of the galactic world is not condemned to simply wait and waste time. After all, they can also approach the DMS question from a theoretical perspective. In general, with the help of their models, researchers can check when we will be able to detect the presence of DMS on K218b. And that's exactly what the group led by Sean Manai from the University of California, Riverside, has now done in detail. The scientists simulated K218b and its possible biochemistry using several models, recreating the planet's covering sea and atmosphere. The researchers then needed to test how much DMS our extraterrestrial microneighbors would need to produce for it to accumulate in the atmosphere to detectable levels, and how quickly it would break down again due to radiation. The study concluded with the exciting result that ongoing data assessment by the team is not in vain, because, theoretically, it is possible that biogenic sulfur gases on hydrogen-rich sea worlds like K218b could accumulate to detectable concentrations. However, as so often, the big but follows. Right now, this only applies if the life forms of K218b are true workhorses. In fact, extraterrestrial DMS production would need to exceed Earth's by a factor of 20 for us to be able to register it with our instruments. This is for the simple reason that the majority of the DMS is broken down quickly by photochemical decay due to solar radiation. In the case of potentially habitable exoplanets, however, a natural protective effect would emerge, which would stop the DMS loss. As such, its degradation products, such as dimethyl sulfide and methane, form a sort of protective shield around the lower atmosphere regions, which are then shielded from further DMS degradation. Anyway, only the future will tell how much the situation corresponds to reality. What is already clear, however, is that definitive confirmation of DMS would be no less than a groundbreaking achievement in the history of space exploration. And while the team at Cambridge is currently busy assessing the new data, as mentioned above, the lead scientist underscores that even one direct detection would be enough to revolutionize the entire history of science. No wonder. After all, humankind has been wondering for centuries whether there are other living things out there, and eventually, a single example would be enough to end centuries of speculation. At once, whether the extraterrestrial life breakthrough will be named K218b cannot be said with absolute certainty right now, but we currently know of no other candidate that offers such a promising lead in our search for life in space. And the path of your video search now leads you directly to the subscription button. Go ahead and click approve and subscribe so you never miss another video from us again. We'll see you soon.